So my first topic under tips and tricks are network checks. In Visum, we have several network checks. Which of those are relevant for SBA? We would generally recommend to carry out, or you can always carry out in a PRT network, the second network check. So that basically indicates turns for which it doesn't make sense that they are open because the to or from link is closed. Relevant for SBA are the multiple straight turns and main turns. We have seen in the previous video that this potentially prevents SBA from being executed, so you need to fix that. Generally, you can also execute all the general PRT checks. Here I will use this one for the speed equal to 0, for example. And it is also recommended to carry out the node geometry for junction editor and A&M. Here you can do fixes that improves the display in the junction editor and has also some benefits when you export junction layouts via A&M to Visum. So once you have selected the network checks, you can execute them. So typically there is then a message with the warnings. If you press show, you can open the message window and here you find some further explanation about the results of the network check. In this case, we have a link that is open for PRT, but the capacity is 0. So in case of SBA, that is not relevant, but is included in the network check. So we do not need to change that. And you should also know in some cases of network checks, you can select the corresponding object and then you have an option to fix that in the network editor. And that makes, of course, improving networks, fixing error much quicker than doing that manually. So network checks are in many cases a good idea to avoid errors. So in this part, I would like to explain how to use a base load with the simulation-based assignment. A quite often use case is that we consider bus services as a base load in assignments, and that is also the case, or that is something you can do also in SBA. So for that purpose, I have introduced here some line routes. And the line routes have also a number of vehicle journeys, and the number of vehicle journeys can serve as a base load for the simulation-based assignment. The base load for SBA is defined within the procedure settings. So we go to tab base load and then we can use the base volume on links and can select an attribute. In Visum, you can calculate the number of service trips for a certain transport system. And we would like to use the transport system bus to reduce the capacity for general traffic. So before we do that, we need first to calculate this attribute. You can see that with the empty circle that is not calculated yet. And we need also a transport system that serves us for the base load. So that is a kind of artificial transport system that will be used in the simulation-based assignment. So there are two steps. First, we create the transport system. That needs to be a transport system of type PRT. That is here already the case. For the simulation, we need to specify the effective vehicle length. That could be for a typical standard bus, maybe 50 feet. So now we have created the private transport system that we need. And then we use a procedure to calculate the number of service trips. So that can be done using the procedure PUT operating indicators. And here we need to select corresponding indicators. So we calculate that for territory and line routes. That is the only change you have to do here. We execute this procedure, and that gives us the number of service trips per link. You can see that here in the list. We can add here also the number of service trips for bus. That is by transport system. And what we need to do is we need to open the link for the corresponding PRT transport system that we have generated, and in particular on those links where this base load applies. So we have this now filtered, and we can group that. And for those links, we add the private transport system that we have created so that we can simulate buses on the corresponding links. So now we can finalize our settings in the simulation-based assignment. We choose the transport system, and we have now here the number of trips for bus services. And now we can run the simulation and get also the base load considered. If you do not use the service trips but another attribute, it is important that you specify that as volumes per hour, so that it can be considered in a dynamic context. So now we run the assignment, so that will take a while. And once that is finished, we come back to see the result in this 3D view. Now the assignment has finished. We change to the SBA visualization, and now we are able to see the base load also in the simulation-based assignment. To do so, you might need to change the graphic parameters. Now the vehicles are not anymore colored by their speed, but by their transport system code. So here we see in yellow now the buses within the 3D view. So next I would like to show you how to model temporary road or lane closures. So a temporary closure means a change of supply during the assignment period. And for road and lane closure, it means that the transport set during the assignment period changes. For changes of the supply generally, we use time-varying attributes in Visum. We can add time-varying attributes under network. Now I create two time-varying attributes for the use case that I would like to show you. So we need an attribute transport system for lanes. And in order to model road closures, we need the same for links. So that is a precondition for changing attribute values over time. So now I would like to show you how to change the the transport system set for a particular link. So maybe we use that link. Once you have added a time varying attribute, you have this tab here, and here you can add a time period. So let's say from 7:30 until 8 o'clock. The link is closed. So that means the value here is empty. So that is one way you can use to specify time varying attributes. And now I would like to show you another way. So we open a linked list. And when you have added time varying attributes, you have additional attributes here. So for transport system set, we have one that calculates the value and another one where you can edit the time varying attribute in the list. So that is a very particular string. So if you edit that in the list, you need to be familiar with the syntax. So if we were to do that the same for the opposite direction, we just could copy that value. And here we have the opposite direction, and we could just enter that, and the opposite direction would be closed as well. So that is a way how you model link closure. In the procedure, you have now two options depending on the objective you would like to evaluate. So you have the option to see the effect if there is an unplanned event, or to see the effect if there is a planned event. So if there is an unplanned event, you can use the current assignment result and just run the simulation-based assignment for a single iteration. So that means we only do a network loading process where vehicle react to the road closure. If you model a planned event, so the drivers are informed, then you would run an SBA assignment in the normal way until an equilibrium is reached, and in that case you assume that the drivers do know about the event. So I skip that for now, but would like to show you how to model lane closures. So for that, we assume that we would like to close a lane maybe on that stretch of road here. So maybe I switch off the link bars. And first I just mark the links where I would like to introduce a lane closure, so later on I can filter that. So I introduce user-defined attribute for links that is called lane closure. So that now marks the links on which a lane closure will be modeled. So here I introduce the attribute, and now I can set the value for the corresponding selected links to 1. So next I can go in the junction editor, and I now have different options how I do that. I can either select the lane, and then I have here the edit time varying attributes. So I do that in the same way as I have done for links before. So also let's assume here we have a closure from 7:30 to 8. And the value is empty because the transport systems are not permitted. And this way I can edit time varying attributes, and also here I can use the list of lanes, and in that list I can now add my link attribute. So I have already a selection of links on which lane closures occur, and I can add the attribute where I can edit time varying attributes. So here I apply a local filter and select the lanes which are on these links. I can also make my life easier if I just choose the approach type, so either the approach to the junction or the outflow. So in that case, I choose the outflow. That is already an edited attribute. And now I can basically copy that, move through my stretch of road and paste the attribute to the attribute. In that case, we close the inner lane. So that means for traffic, there will be still one lane open. So now I have essentially closed the inner lanes of all the links that I had selected. And now I can run the simulation-based assignment and can see the effect then in the SBA visualization. So that will take a moment. So once the assignment has finished, we can check in the SBA visualization. So let's move to the point in time of 7:30. So here we still see that vehicles use both lanes. And now we will see the change. So vehicles move to the outer lane and the inner lane is not used for half an hour. And if I move to 8 o'clock, we can see that at this moment the vehicles change to the inner lane as well. So that was a way how you can model time varying attributes. So next I would like to explain you how to make use of different time definitions. So in our Visum model, we have used already different time definition. We have first here the analyzed time intervals for which we obtain result. We have used time series for demand, and we also added empirical data, which also were available for time intervals. So in Visum, we have for that purpose time interval sets. Currently, we have created such a time interval set for the period of the assignment period. So that is from 7 to 10:30 in 15 minutes intervals. So maybe we add this information. And you can also create, of course, time interval sets in this list. So now we do that for 5 minutes. So you can just edit that, enter the start time and the end time and the duration of the interval. So short time intervals are sometimes useful to find the onset of congestion in a simulation-based assignment, and you might need to change the assignment time interval to this 5 minutes. So you can simply do that using the context menu, but of course that would require reassigning the demand. We have also used time series for the demand. So here we have, for example, the matrix time series, which we have created in 30 minutes intervals. And also here in this dialog, you have the option to create such matching time intervals. So that would be now time interval set for the period from 7 to 10 and 30 minutes intervals. So how you can use this time interval sets now? Of course, you can reuse that for demand definition and for the analysis periods, but you can also use that for the creation of user-defined attributes. So for example, if you have counts available in certain time intervals, you could make use of these time interval sets, which are independent from the analyzed time intervals. So in my model, I have already counts. They were defined in 15 minutes intervals. So, and by having the other time intervals, I also can aggregate my count values to any intervals that are also available in the network. So in this case, I could just go to my count attribute, and below the time intervals, I find the other time intervals, and I could now here choose for the third interval, 30 minutes aggregates, and I would like to have that as a sum, maybe for 7:30 and 8 until 8:30. So I can also list the attribute in different time definition in listings. So that makes it easy to compare those data to results of the assignment, for example. So that is a way how you can make use of time intervals in Visum, in particular to compare results. So next I would like to explain how to evaluate the level of service for nodes and to produce an ICA report, which is a detailed calculation of node performance based on highway capacity manual standards. So in order to do that, I need to make two changes. So let's assume we do that for signalized nodes in the network. So first I need to change the calculation method for impedance at nodes. So I filter here signalized nodes, and I need two attributes to change the method for impedance at nodes. So let's assume here we do that for signalized nodes, as I said. We can activate that for all the corresponding nodes for which we would like to have the calculation. And then we can also change here the calculation method to node impedance calculation ICA. So that is the first change I need to do. And then I need an appropriate value that represents here the design hourly volume. So in our case, the assignment period is not 1 hour, but longer. And because I have the results of a dynamic assignment, I would like to use more appropriate values. So in this case, I will store them in atval 1. So I will include that in the procedure sequence, create a group for node evaluation. So and now I create procedure edit attribute in which I will fill at 1. So that needs 4 turns. And my attribute is at val 1. And as I said, because I have dynamic assignment results, I will use the results from the assignment, from the time intervals, but have to make sure that it's an hourly volume for the turn volumes. So I can use either 4 times a single interval, or I can choose for consecutive intervals. So maybe 8:15, 8 o'clock, and maybe here 7:30. So if I sum that up, I have the hourly volume for turns. And once I have that, I can use the update impedance at nodes, which calculates the level of service and produces the ICA output. So now I run these two procedures. And in the node list, I have now the results for level of service and also level of service mean delay. So that can now also be displayed in the network. Additionally, I get the output in the ICA reports. So for each of the signalized nodes, you have a single sheet where you have the detailed calculation, including the intersection delay, level of service, and so on. And if you would like to change the method, in that case, you need to change here to a different HCM calculation. That is also possible. So that is a way how you can calculate level of service for nodes and average delay, for example.